If we have two spinning shapes like this, and then we separate them, I noticed that their velocities are not correct. So if we make one of them single in the test here, we can see that they separate like this, whereas they should just both separate evenly away from each other. This happens because currently I update one shape at a time, and when we split this shape away, then that directly affects the velocity of this shape, and then we lose the information. So I believe the solution is to go through all the shapes beforehand and store their current velocities. Then we can split them, and then we set all the velocities so they're correct. I think the angular velocity is always fine because that doesn't change depending on where the shape is locally to the body. So this is the test I wrote for it, and it's failing now because the velocity is not the same after we split it. So let's try and fix it. A coffee and a notebook page later, I think I have a plan. So like all the functionality is pretty much there. I just need to clean it up and make it unified. I have a few different like scenarios here that should all be handled by this new system. And I believe the common denominator is all we need is a list of shape sets. And a shape set is a list of shapes. So when we combine two shapes, all we give it is a single shape set where those two shapes are there. In this one, we have two shape sets with one shape in each, and then in this one we have one shape set with 5 different shapes. And then like imagine this is attached to the square there, and then we detach this one, and then we're gonna have 4 shape sets. Single one on the left, single one on the bottom, single one with the one we detached, and then the right one is gonna have 2. I believe that should work. Currently the center of the body isn't always on the center of gravity, so when I do have to calculate the center of gravity, I have to run an expensive function to get it. But what if we just always recenter on the center of gravity? And that's related to this as well. So what if we never keep bodies? When we combine, for example, up here, we just delete those 2 existing bodies and we create a single new one. Here we delete the single body and we create 2 new ones. And then every time we create a new body, we can just make sure that it's gonna be centered on the center of gravity. And now that we do like all shapes at once, we can track all the initial velocities. And here are all the relevant methods that I believe I wanna merge. Maybe leave some of them, but they're going to be super simple and just use this main new function. And then this is the tricky one, but this is going to be a bonus. So dynamic merge velocities. These 2 shapes, for example, merging those, imagine they're actually traveling towards each other. And then at the moment they touch, they merge. Then they should just stop, right? If we assume that they weigh the same. But then if the right one is twice as heavy, then it's going to move a bit to the left. And I don't think that's something the engine will help us much with. We're going to have to calculate that ourselves, because once merged we cannot set individual shapes velocities, we only set the entire body's velocity. Perhaps to solve the velocity issue we can just track the initial velocities of both of them, and then when we create the new body it has a velocity of 0, and then we apply force at the center of this shape in the direction it was traveling, and we apply the left shape's velocity from its center, and then that's going to be multiplied by the shape's mass, and then we let the engine calculate the final body velocity and also even angular velocity, because if they're offset they're gonna start spinning a little bit, right? And the spin is also 1, so imagine if these 2 are spinning in opposite directions, they should cancel out. But if the right one is then heavier, then its spin should transfer a little bit to the new mass. And perhaps we could do that with apply force as well, but maybe we could just calculate it. I wonder if we could just take the weighted average. You can worry about this last one in the end. I think this is a good plan. Slowly getting there, but now we can actually see some fruits of the labor with the new updating compounds method. So in this test we have 2 shapes, we attach them, and then we apply angular velocity to one of them, but then we want to see a symmetrical rotation, and we do. That might always have been working, I'm not sure. But then in this one, same setup, but we split them, and then we make sure that they act symmetrically. Let's show this one. And yeah, I think that's perfect now. We can see if we keep them attached, it looks like that, moving up and rotating counterclockwise. And then we make one of them single, doesn't matter which. Yeah, that's so nice. So now in our custom shapeset class, I added a new body method. Previously we only were calculating the center of gravity here, But I thought, let's just create the entire body and get it ready. And then we call that in the update compounds method. But this one is pretty interesting. So just like before, to calculate the center of mass, we take the average weighted position. And since I have such huge numbers, AI helped me rearrange the formula so we can keep the numbers lower. So for each step, we just add with the relative position times this shape's mass as a percentage of the whole. And apparently that adds up to the same thing, which is pretty cool. And then we can do the same thing for the velocity. This thing surprised me. But this is from getting the inertia and the moment, and then the new angular velocity. So I got some help with this as well. But this surprised me with the velocity, because I thought if you have two moving shapes moving towards each other but at an offset, that it doesn't I thought it would create a new velocity somewhere else, but now here that it showed that you can just take the average, say the weighted average, same as for the center of mass. It means that the offset is irrelevant for the new velocity. They can be traveling like this, but the new velocity is going to be 0 if they travel at the same speed and they have the same mass. Or if they go directly towards each other, the new velocity is going to be 0. It cancels out. And that's pretty cool, but it makes sense when you think about it. Then the last remaining piece is to get the angular velocity, and this one requires some heavy math. So apparently you divide the moment with the inertia, and that's how you get the new angular velocity. And apparently this is how you get the inertia and moment using the cross product. Yeah, this is beyond me, but it seems to work really cool. So I made a lot of tests, and we got some cleaned up methods for the shape set and the shape set list. I've done a lot of work on our custom sequences here, and I've implemented some nice quality of life methods so we can just add these together or subtract, and we don't need to worry if it's the container or if it's the item inside. I got all the type checking working, so we get nice autocomplete. Very happy with this. And the one issue I had was when we compare these lists, because shapeset list is a list of shape sets, and then the order matters. But I wanted a way to compare lists and ignore their order. So initially I thought I would change this to a set, so we would have a set of sets of shapes. But then I learned that we can't have a set of sets because its mutable sequences are never hashable, and that makes sense. But then I learned about frozen sets. So then I thought, okay, I'll make the shape set a frozen set. But then I realized how many places I actually mutated. So I reverted that. And then I thought maybe support both frozen set and set, but that's going to be too messy. But then I even just went back and made this a list again, because the actual problem, this was an XY problem situation. The actual solution was just having a function that can recursively compare sequences that aren't hashable. So I'm pretty happy with this general solution. We have a deep unordered equal, just compares the IDs of the items no matter how deep they are in the nested sequences. And we compare them as frozen sets. That's pretty cool. And I use that for all of these tests. So for example, here we have a sequence of shapes, 5 squares in a row, and then there's a space between index 2 and 3, and then we give this method a shape set of 2 and 3, and we ask it to split to make sure they're all touching, and then we expect to get back a shapeset list with 2 and 3. That's not a very useful scenario, but very good to test. Same thing here, 0, 2, and 3. Neither of them are touching, so they should all be individual there. But then here we go, so 1 and 2 are touching, and then 3 is the separated one, so then we should see those two grouped together. But then like the order doesn't matter, because we're not sure in which way it's gonna return, since this is a set. It might iterate in a random order. So very happy with this, and now I'm just it's been a lot of refactoring, and a lot of the tests are failing, but I'm getting there. A lot of it has to do with the joints not being handled in the new update compounds method. So that's probably what to tackle next. Well, that was a bit annoying. My recordings haven't been saving for the last 4 days, I think. Something like that. Since I updated my driver, and I had to update my driver because I updated Windows, and Windows messed up AMD somehow, and yeah, Windows sucks. God damn. But now I believe I got it working again. It was an issue with the microphone. If I disable the microphone, then it would record like normal. So some permission crap there. But then I updated my headset driver, and now I believe it's it's working. So, the last days I've been focused on adding this new hook function, because the old one we had was not very good. We had to write identical method names, which was a bit frustrating. Especially, for example, when we profile, then they all get merged together and we can't see what's taking all the time. Another downside was that in order to propagate like from the view to the body, to the shapes, to the modules, to the actions, I had to write a method for everything that I wanted to propagate in one way or another. But now, we have, for example, here's one of the view parts, and we can just say like run this function on init, and the order doesn't matter, so we just put it to 0. And then this one we want to run with the update function because we're calculating the FPS. So here it's just hooking into itself, but the cool stuff is when we get like into like action that's really deep down, and we can just simply say that we want to run this method for all the actions on update runs for the view. And this one is a bit special though. It seems I can't decorate these methods directly. I mean these, because when Arcade Pymunk, when Arcade runs these methods, it doesn't call it the normal ways. So then we simply add some dummy hooks here, and this is what we hook into, and that works like usual. And this is the only place where we have to use that special treatment. So I think this really has potential. I have been working on like the hooks themselves for like 2 days. I've added tests for them. Let's check those out actually. So we have all of these here. Wait, this one fails now. Did I change something? Oh my god, all the tests are passing. Added a few more tests for the hooks. We can now hook like indirectly. Like in the A class here, we can hook into C, which is actually a property of B. And have some nice recursion detection if we like trigger on ourselves, or like even more complicated recursion than that. And I've updated all the code. It's working now. We can run all the tests and it's so nice. Like our, for example, now for the zone, when we want to draw the poly, showing where the zone is, this is all we need to do. We just say that we want to trigger this when view uses its own draw. We don't need to propagate anything. Like it's all handled automatically. It's so cool. I introduced this delete method structure, and we have some propagation going through that way, but it's much nicer. So like it starts in the body here, and then oh, right, this is something I want to try. So if we directly delete the body, we should also delete all the shapes, and then that should trigger the like deletion of modules and actions. Oh, okay, but we can make this better. We want to trigger the shape deletion when we delete the body. Yeah, and we want to trigger the body deletion when we delete the view. That's better. You can see for the module, we trigger this on when we delete the shape, and then for the actions that need it, we can just implement a delete method there and trigger this on when the module is deleted. And the reason for making it a general structure is because in the hook mixin class, I make this trigger on delete, so that it tries to hook into the delete method if it's defined in the object in which the class has the hook mixin subclass. So then if we delete like a shape, we delete all the hooks that are hooked into the view, into the bodies and stuff. I'm sure we're leaking somewhere. I haven't implemented any tests to make sure all the hooks are properly cleaned up when we delete shapes and stuff, so I could take some love there, but like it's working now. I'm so happy. I can actually run the survival. It's been like a week. Slowly getting the game working again after all the iterations and refactoring. And I've just implemented this. I've always had a way to debug a position, but not a direction. So I made this function also take a direction, and then that creates an arrow. And then I also needed to see the order in which these arrows appear. So I added text support as well. And I got rid of the black backgrounds because now we have the color palette, so we can actually always read the white text, I think. So these arrows and numbers here are for when I'm spawning the zone. And for some reason it's broken after the updates. But looking at all the steps here created by this method, which is used to create various structures, it's simply we want to pick a random point around a planet, and we want it to return the position and the angle like of the surface. And I had issues like where it would pick the pointy ends more, and yeah, just not align things perfectly. So this was the method I ended on last time. It's kind of hard to look over there. Let's do it like this so we can move the camera. So this is how it works currently. We start here, and this is from this method, which is we can simply say just shape.surface, and that takes the bounding radius at a random angle and just returns that. And I had a bug here because for some reason I chose to make this local, but then when I was using it, I was using it as a global or like a world coordinate. So that's one bug that's fixed as well. Or no, it's not a random angle. So I set the angle here, and that's how we can set up the starting conditions. So just get the angle like straight up there. For the zone, but then we can't just put it there because then it would be in the air and stuff like we see here, like the one is in the air. So then what we do is we step away 100 units in the opposite direction of the gravity, which we can see there, number 2. And then number 3 is when we do the first query, and we query this position onto the planet, and then we get the closest position, which is 3. And then I guess this is where I thought it would often choose the point. I think it's because I used to have this much higher, and then the likelihood that it chooses a peak is much greater. But now that I'm using planet.surface, it's actually giving a better result right off the bat. So this whole algorithm can be simplified greatly, I think. So then number 3 gives us a new direction pointing up, and then we rotate that 90 degrees and we add 500 units that way, and then 100 units up again in the same direction that's pointing. And this was to get off the peak. And then number 5, we just query again, and that's the final position. As you can see there, where the zone is. But that's a perfectly fine zone, but still the zone is messed up. So there's something else going on as well. But getting there. Been trying to figure out why this happens when moving things. Now it's paused and it works fine. But if I resume the game and pick this back up, then it's over there. So it seems to be affected by the velocity somehow, because we're actually traveling very fast in that direction. We can see the arrow there is the velocity because we're orbiting the sun, right? So I was thinking maybe I'll just make the game paused if you're moving things, but that's not a good solution. So I tinkered a bit with it and I try this, because before we were changing the position to be relative and looking at the starting position. Then I thought, okay, so that might be what's causing it. So let's just try and setting it directly and not use local to world. And I initially only set it to the position because I wasn't sure exactly how to implement the rotation. But then, yeah. This works perfectly now. Now it goes to the center. It doesn't take into account where I grab it. But then this got me really excited. And then I figured out how to just rotate the local vector to the body angle. This seems to work well. I can actually stay inside the zone now, lift things. Anti-overlap works great. Oh, and this is a new improvement I made as well. We can, it doesn't stop when you touch, but it tries to move it once, see if it can resolve the movement. And if it can, then we just use that. But if it can't, then it freezes. Like here it probably tries to move to the other side, but since that's not allowed, it's gonna freeze. Really cool. But initially for this code, I thought it was something to do with the order of operations here. Because at order number 1, we have this, where we do the stepping. And then I update the cam with order 2, because that's taken into account when we calculate the mouse position. Stop the alarm. Sound is ready. But it wasn't that either, because yeah, you can see the circle where the cursor is. It's perfect. And then thirdly, we have order 4, which is to actually call the move interaction. So the order seemed fine. But yeah, setting a relative position doesn't seem ideal. This seems much more stable, and I'm really glad it works. The fix I thought I had made was not really correct. And upon further investigation, yeah, you can see it jumping. Like, I don't even think I got it right. It's very strange. And then when moving multiple shapes, they try to move them together, but the new collision detection automatic movement makes them stay together pretty nicely though, so that's cool. And they're actually just welded if you let go. But yeah, this is not the fix. So I went back to this again and I landed on just doing this again. But I believe I was using an old position. I wasn't using a fresh value for the mouse position, which is why I got the weird behavior, because now it's perfect. So exactly when I click, that's where it's gonna lock it to. But then we have the delay because it doesn't know if we're gonna click to select or click to drag yet, which is why it jumps. I went over that in a previous devlog. So this is perfect now, except I found if we move both of these, this works nicely now again. Move like this. And now the issue is with the new collision thing that I tried to automatically move it. I didn't think about moving multiple pieces because I don't want to allow this. I want to stay locked together. Here we go. So this is the fix. Trying to move the shapes, but the issue is I'm only trying to move the single body, which this is called on. But we need to apply the same movement to all the bodies, and that's here, move interaction. All right, so it's in the view, so we can just maybe this, we can make this return the relative movement, or just a movement, and then we get moving bodies, and this is what we iterate. And then is this a body set? Yeah, so maybe just something like this, and then oh no, I was thinking we need to keep track of the original positions. However, I think that's fixed here already. So we can move any shape however we want. And then if any of those fail the overlap check, we raise the error. But now we need to run this on all the bodies. What if we make this a bit more robust? Because I really like this system. And but sometimes it fails still. We could make it a bit better. Wait, what's this? Oh, we do an overlap query right there first, actually. So it might be down there that we want to iterate. So let's start on something entirely new here, actually. I'm thinking we iterate all the bodies here. Do like 5 attempts maybe, and then we iterate all the bodies, and then as soon as one of them is overlapping with something, if you're not overlapping, we don't care, so we just continue. Keep the indent a bit smaller, and then I guess this is the colliding body, and we just assume. So this we could make a bit more robust as well. Although it doesn't matter because we're just gonna take. I was thinking we could iterate all the bodies it's colliding with, if multiple, but no, it doesn't matter. We can just take the first one like this. This is the colliding body. And then I feel like we need a recursive function here. I guess that's the whole point of the for loop. So it's gonna be this. So it's not self, it's body, and it's with colliding body, and that's the movement. Let's make this return the movement. Optional v2, and then it's right there. Perfect. That was pretty easy. So then we have the movement, and then we apply this to all the bodies again for body 2. For body 2, and then if body 2 is body, we continue because we've already moved that one like that. And then now that we've done some movement, I think we break this. And then if we haven't broken it, we break this one because that means there's no overlap, I think. And this could work. Wait, we still need to raise this though. Oh, is it like this? Then if we never break this, this is where we raise the fail move. It's not very readable code. I'm not even sure it's correct. So what do I want to do here? Well, we can break there at least. That makes sense. But then else on for loops never makes sense. It's never readable. So I guess it's like this. No overlap. We assume it's true. And then if no overlap, then we can break. Then I wonder, could we do... Yeah, so what if you just set it there as well? It's kind of silly though. Like, why do I get that warning if we have a static range of 5 we're iterating? I guess that works. It's not pretty. It's at least more readable. Let's see if it works. Okay, yeah. So far so good. No. Whoa. Oh, right. I did minus equal on the movement in here. So let's just go minus there, and then we do plus there. Ooh. Oh no. Then other. Okay. Wait. Why did? Oh, if you're none, we just continue. Because sometimes when we try to move it, it might fail. Like if it's not deep enough inside, or if it fails to get a query, and then we just continue if so, and try the new one. I think. Is that right? Yeah, I think so. Oh yeah, nice. Let's get a pivot joint in there. Perfect. Like it works so well. It's boring now, you know. But that's the way you want it. Do I notice any difference if we just do one iteration here? Oh yeah, big time. What about 2? That's a funny boulder. One scrap. Dunk. Oh yeah, it's much better, but it's still not as good as the 5 one. Yeah, just leave it at 5. Why not? Cool. And the next bug to fix is if we have a pivot joint like this, and then we attach something new to this, and then we play, you can see that pivot joint quickly disappears. Or it's like, this still works fine. And it actually happens every time I attach or detach something. And it's because there's a hook that's created for the pivot to draw the pivot itself. But this hook is only cleaned up if we call delete on the object. This is my general hook mixin class now. And I just remembered I wrote this warning that I had commented, but now I enabled it. So we can actually see all my classes that don't implement delete. And I believe if we implement delete for joints to begin with, we should fix that bug. So let's see, we have a bunch of, I guess it's only these two. So this one deletes itself. This one deletes all its children too. I feel like we should make this one then. This is only, no, yeah, like that. And let's run this again. Nice, a bunch less warnings because I have a bunch of classes that inherit from joints, one for each different joint type. And now create a power pivot joint, doesn't matter. Sure it works actually, yeah, looking good. And let's attach something. Nice, detach, yeah. We have this arm here, and I had an issue where when we were colliding this, then the game did not like that. But I seem to have fixed all the bugs now, so we can ram it into there, no problem. And even here, like take a look at the length of this arm. When we crash it here, it's going to be removed, but then the distance between these two circles is beyond the threshold, so it's actually going to remove that joint. Then if we zoom in here, you can see what happens here when I collide. See, we still have the single joint up there. That's very fun. That's really awesome now.